All right, so welcome back. Today's video is going to deal with this thing called the tangent line. You're going to do this a lot in calculus. That is the backbone of calculus. This is something that we do a lot right in the beginning of calculus, at the beginning of the year, and we do it throughout. It is a common thing, and it does a lot of stuff. A tangent line is something that will help us find how fast something is changing. It helps us find a slope and things like that. In fact, that's essentially what we're going to be looking at, is we're going to be looking at the slope. Now, when we do slope of a line. Notice my graph here, which I need to label up. My graph is f of x. Notice my graph is not linear. And finding a slope between 2 points on this graph is super duper easy, right? We can just do y2 minus y1 over x2 minus x1. Our job is going to be to find a slope at one single solitary point, which is really weird. So say we have this coordinate right here. We could find a slope, and we could draw a line that goes through that point. That point is on the blue graph, but I'm going to draw a red line that goes through that point. Like so. That's not going to be good. Let's delete that. Let's try it again. This is going to be better. Yeah, that's really good. There we go. Okay, so that line goes through the coordinate on the blue graph. It touches the graph. That's what a tangent line does. It just touches the graph. I can draw a few more of these in here if we pick another point, say this coordinate right here. We can draw a line through that coordinate, and that would be the tangent line at that point. Okay? At the bottom of the graph, or at the top of a graph, I'm just choosing the bottom of a graph, we could draw a tangent line that looks like that. So in this picture, we have 3 red tangent lines. The slopes of those lines are the slopes at those specific x values. So we have 3 different x values. We have an x value here, we have an x value here, and we have an x value here. We can get the slope at that one single solitary point. And we can do that by looking at this one limit and this one equation that's going to become very, very familiar to you. So what I want to do is I want to take a look at a different graph. So let me draw a different graph up here. All right, so I have a much more basic graph here to look at, and our job is going to be to figure out how we could find the slope at one single solitary point. So the way that we do this is we start by just picking any 2 random coordinates. It makes no difference what coordinates we pick, so I'm going to put a red dot at this coordinate right here on my blue graph, and then let's go green, and let's put a dot right here on the graph as well. So I have these 2 coordinates. Now I'm going to label up those coordinates. Now for the red dot, I'm just going to draw a line down here. That is a distance x. I don't know how far away I went from the origin, and I really don't care how far away I went from the origin. We're just going to call that x, right? And so then this coordinate, if we label the coordinate, would be x, comma, the y value. Now I could call it x, comma, y, but we're not going to call it y because we use function notation. Our function is f of x, so this will be x, comma, f of x. That's the coordinate of that red dot. Okay? I'm going to do the same thing for my green dot, but with my green dot, I'm going to do things just a little bit differently. Instead of calling this x value something different, like x1, x2, I'm not going to do that. Instead, I'm going to relate this x coordinate to the x coordinate that we already graphed, to the red x coordinate. And the way that I'm going to do that is I'm going to say that the distance between this x value and the x value that I'm about to label, I'm going to say that that distance is a distance h, just to give it a letter name. Okay? And so then our x coordinate for this green dot that I have up here, this distance would be whatever x is plus whatever h is, right? Because we always measure from the origin. So that total distance to the green dot is going the red distance x plus the black distance h, which gives us the total green distance of x plus h. Okay? The coordinate up here, up at the top of our dot then, just like we did with the red dot, we'll do the same thing. This coordinate would be x plus h, comma, now we could go y or y1 or y2 or anything like that, but we use function notation, and so it would be f of this coordinate, f of x plus h. That's the coordinate of the green dot. So we have our 2 dots, red and green, and they are just 2 random dots on this graph. we could connect those dots with a line. I'll do that in purple. And so if I connect those dots with a line, it would look something like that. That line is not a tangent line. A tangent line, by definition, and if we think back to our integrated math 2 when you did circles, a tangent is something that only touches once. Now, a tangent line does have the ability to touch more than once, but it only touches the graph guaranteed at one spot. This purple line touches the graph in 2 different spots, so it's not tangent. Tangent means it just barely intersects. So before we get to what a tangent line and drawing the tangent line, this purple line that's not tangent, it's actually called a secant line. You don't need to worry about that now. You'll worry about that next year in calculus. This line that we've drawn by just connecting these 2 red dots, the red dot and the green dot, we can find the slope of that line. And we can do that slope with old school algebra. Remember our slope formula, m slope is equal to y2 minus y1 over x2 minus x1. Well, if we look at our dots, I'll use the green dot as x2 and y2, and I'll use the red dot as x1 and y1. So we need our y values on the top. So my green y value is f of x plus h minus my y value for my other coordinate, which is just f of x. And all of that will be over my x coordinate. So my x coordinates are x plus h minus the other x coordinate, which is x, right? That's just the slope. That's all that is with the representations that we have. Now, if we clean this thing up, we end up with a slope equation of f of x plus h minus f of x all over just h, because the x's cancel. This has a very, very special name. We call this the difference quotient. It's just a way to do slope. The difference quotient. It's a way to do slope without 2 coordinates, because you notice I don't have 2 coordinates. I have 2 different things that I need, well, 3 different things. I need the function f of x, so I could do f of x and f of x plus h. I need my x value, and then I just need h, the difference between the 2 x values, and I'm good to go. Now, we're not just going to use this formula. This formula is just slope. It's no big deal. I could do an example where we just did slope. I don't need to do a slope example with you. That's integrated math 1 or even before that. What we're going to do is we're going to look at how can we get this purple line to just be tangent, to just touch the graph at one spot. Because right now, again, it touches it at 2 spots. The purple line intersects at the red dot and the green dot. We want to bring these 2 points close together, right? So if I'm trying to, and my goal, I guess I didn't state that initially, my goal is I would love to have the slope just at this x value right here. I want to know what's the slope of the graph right there. Let me get rid of that circle. If I were to draw a tangent line in there, let's go ahead and draw it in green. I already used green. Let's draw it in orange. There we go. That's a color I haven't used yet. If I were to draw the tangent line for the graph at that 1 red dot, that's what the tangent line looks like. That is very different than the purple line. My goal is to make the purple line look like the red line, the orange line. I don't even know my colors right now. How can I make the purple line look like the orange line? Well, if I take this green dot, that's why we're using colors. If I take this green dot and I move it this way, closer to the red dot, then that purple line is going to start to the slope is going to be less steep, right? That if I move that green dot, say, to here and connect the dots, that's what the line would look like, right? It's getting closer to the orange dot. If I move the dot to here and now connect the red and that dot, look at that, it's almost the orange line. So my goal is to bring these dots as close together as possible, so that way the purple line becomes the orange line and I end up with a slope at one single solitary point. Well, how do I do that? Well, if I'm going to bring that that green dot closer to the red dot, then my goal is to make h close to 0. Because if h is 0, then that means the 2 dots are right on top of each other. But I can't do slope with the same coordinate, so I don't want h to actually be 0, I want h to get close to 0. We have been studying something over the past couple of videos that does this exact idea, the idea of bringing two things, or bringing something close to a value. It's called a limit. And so, oops, didn't mean to make that mark. And so if we want the slope of this tangent line, this is the big idea that we will then look at in our next video. The slope of a tangent line, or we can also call this the slope of the graph, because that's the same thing. But the slope of a tangent line is simply the limit as h approaches 0 of f of x plus h minus f of x all over h. This limit equation is something that you want to have locked in. This is something that you're going to use in calculus. We're going to do it a ton in calculus. We're going to do a bunch in the next video and look at examples of how this is used. But this formula, finding the slope of a tangent line, is super big and really sets the basis of calculus. So look for the next video. Head on over to the next video, and we're going to see how to use this to get the things that we need.